TTL Computer II. Today, we're going to take a look at the backplane build out, and we'll also look at some other updates that have been made uh, in preparing to really begin my first circuit board, which I'm pretty much ready to do at this point. Okay, so let's dive into this. So we can see that a lot of these elements we've had on our backplane before, our L bus and our left bus, our right bus, our address bus, and our data bus. This has been added to the backplane just to build out the backplane. And these are all of our control signals. And I have these basically grouped into control signals needing pull-ups and control signals needing pull-downs. And then I also have the clock signals off here to the right. And we're going to keep those a little bit separated from the rest of the signals if we can, since these are going to be the highest frequency signals. And then I also added, so we'll have one active element on the backplane. And this is just a Schmidt trigger inverter that we are going to use just to clean up and sharpen up the reset signal and do debouncing. And so that's what that's going to be for. Now, you may notice that we're missing some things here. Really, the run and the program switch, that's gone. So I've gone through a lot of hashing and rehashing in the last week about my approaches here in our physical design, and it's really been centering on how we're going to accomplish the board testing. And I've gone back and forth on the approaches and a direction. But we basically had two directions that we could go. One direction would be that we put all of the testing and the display elements that we would need to to prove out the design, the circuit board designs. We would put all those elements and build them into the backplane, like all of our data switches, visual indicators for the status of the buses and the control signals that we'll need to be able to do that to validate that the boards are operating correctly. That's one approach. And the other approach would be that we won't put any of that in our design, and that we'll make a testing card, a testing board that we'll plug each of the individual cards into, right? All of our control, the register card, the memory cards, that all of those would plug into. And I originally decided not to go that route. And one of the reasons was that all the cards are going to have different pinouts on the cards. And that was like a major drawback in my mind to do that. Plus, I felt like doing a testing board was whole extra design effort, and I wasn't wanting to go that way. So, we're already familiar with having our instrumentation, in our simulator. And so I went off in that direction, and I started adding all those elements in to the backplane, all the switches that we need and all the display elements. And at a high chip count. And I also had to add some extra chips to some of the other printed circuit boards to enable being able to work with the backplane board for doing diagnostics. So I actually went down that route, and I did the design, and then I was starting to not like that approach because the chip count was going really high, and I'm starting to get concerned that we might have, power supply issues with the chip counts being so high. And so that was making me start to revisit not having the testing elements, in our regular boards or in the motherboard, and building a testing board. And that's the way I swung. My pendulum has swung back. And that's what I've decided that I'm going to be doing. And I also as part of reviewing that, you know, my intent here is this is not going to be a blinky lights computer, right? We have lots of blinky lights in our simulator, and we had blinky lights in my TTL computer, but that's not the intent here. My intent here is to have, you know, a usable computer that we're going to use and program in a traditional way. So I went back and I ripped all of that out of the design. You know, the run program switch is gone. I even pulled out circuitry that wasn't going to be needed if we weren't going to have this programming mode. I ripped all that stuff out. So we'll briefly look at let's jump down. We'll look at the clock circuit as an example. Open that up. Now you see our chip count is way down on the clock. So I eliminated all of that circuitry that we had, which was like four additional logic chips that when the run signal went low, you know, it monitored for the to get to the not clock state before the clock would stop. I just eliminated all that stuff because in practice we're not gonna do that. We're always going to be in running mode, right? Running on the high speed oscillator. So in our final hardware, we're just going to have our high speed oscillator. And what else? So all that extra circuitry is gone, and it's greatly simplified, you know, certainly the clock design. Another thing I did in all the cards was that in digital, digital makes a distinction between an input and a tunnel. And digital allows you to name an input or an output the same as a tunnel. But once we get to our circuit design, we're not going to be able to do that because in our circuit design, these are both the input and the output are going to essentially be tunnels. So we can't have them be the same name, or we'll have a conflict on the names. So I went in and updated all of the designs, and what I did for the tunnel is it takes the same label as the input, but it adds a lowercase l in front of it for local. So this is the not clear signal, and on the board, it'll be called the local not clear signal. So I went through and updated all of the designs for that change. Okay. What else? Also in the control circuit. So what I did here was that, so we're going to have two testing approaches. I'm going to build for each individual car, for all of the printed circuit board cards, I'm going to build one single testing board, and that testing board will be used to test all the boards, and they'll pretty much have some display capabilities on there, and then abilities to, make all the signals that will be required to test the board. So all the boards are going to be tested with the same testing jig. But what I also did, I wanted to, if necessary, and I'm hoping that we won't even have the need to do this, is that I can make a second testing board that will be used in place of the control, in place of the control card. And that will allow us to test, if we need to, all of the data flows within the computer. Because all of the control signals come into the control board, and the data bus comes in here as well. So we'll pretty much be able to control all of the data flow in the computer if we need to. And I said my hope is that won't be required, because we're going to test each board individually, and then so that means the only thing left that's a little bit questionable will be the backplane board. But we'll have to use a little bit different testing techniques for the backplane board. But that's really going to just be, point-to-point connection testing, because that's pretty much all the backplane provides is, are all the buses. the bus connections. But so what I did here on the control interface is I added these two extra clock signals that really are not needed for the controller, the U clock and the T clock. So this way, all of the clock signals will be on the printed circuit board, interface, card level interface. If we have the need, this way we can pretty much control all of the data flow in the computer with our control level card, our control level testing board, if we need to do that. But again, my hope is that won't be necessary. Okay, so I've made all those updates here. I don't think any of the other boards, the control card, I was able to eliminate a couple of circuits that I had added because of the build that I did in the backplane with all the switches and everything. But I removed that, so that's all gone. And so our chip count is acceptable, I think. But when I started adding the extra circuits to again have all the testing elements on the motherboard and the display elements on the motherboard, I was getting uncomfortable with the chip count. So this is everything above this line is really what we're going to see on our motherboard. We're not really going to have any display elements other than power indicators. And our first thing in our solution that's going to give us some output display capabilities will be the hex display. I'll probably build this card. We'll build this card as a display that we can use in our solution. And then the next thing we'll do is our serial in and serial out cards. So I think that kind of brings you up to date. I've kept my old design of the simulator that has all of the switches in it. So I'm going to keep that just to have in case anybody wants to use that to play with. Well, so we'll still have that. But I'm going to skinny this down. This is skinny down now to what the actual build is going to be. So I've already started ordering components. I've found and ordered the card edge connectors that we're going to need. And I think at this point, since I've made this skinny down the design here and have a direction now decided on, I'm ready to go ahead and implement the first card, which is going to be the clock card. And then once that's done, I will start to work on that testing board. And then another reason why I came off of the approach of having all of the testing elements on the motherboard was that I would have had to finalize all of the card edge connectors for all of the printed circuit boards now, because we would need the backplane in place to be able to test our individual cards. So that's a major drawback in my mind, is that all of the card edge connectors would have to be designed and have to be 100% assured that those are correct on the first go around. And that was just a really big drawback in my mind. I didn't want to have to do that now. I much prefer building a board at a time, having the manufacturing done, testing out the card, and then knowing that the card edge is complete and accurate, before having to throw that all into the motherboard, the backplane, at the beginning. It just makes a lot of sense to do the backplane last, after the individual boards are all tested and the designs are finalized, then bring those, the card edges into the backplane as our final integration testing. So that brings you up to date. It's been about a week since my last video, but a lot was going on. I said back and forth, a lot looking at doing some test designs in Easy EDA, which I'm going to be using. EZDA and JLC PCB for the printed circuit board manufacturing. So I've been doing a lot of playing with that and testing, and so a lot of work's been going on behind the scenes. But I think this brings you all up to date, and I think maybe my next video will be we'll have the clock card circuit design done and the printed circuit board done and just ready for submission to production, and that'll be our next video. So until then, that's it. Thanks for watching.